Welcome to True Projects. In this video, we are going to discuss about the project which is a solar energy predictor using machine learning and deep learning. So before getting into the execution, let us understand what is the project about. So why is solar energy important nowadays? Traditional sources like coal and fuel they are running out and using them creates pollution that harms the environment. And also climate change is becoming a big problem and using fossil fuels makes it a worse. So how does the solar energy helps this problem? As solar power is clean and renewable source of energy, it doesn't produce pollutions like fossil fuels do. Using solar energy, it helps in reducing the gases that cause climate change and makes our energy supply more reliable and safer for the future. Do you know why solar energy is considered as renewable resource? It is because the sun is always shining. Well, at least during the day. And the best part, the sun will keep shining for billions of years, so we won't run out of the solar energy like we might with fossil fuels. Let's talk about the cost effectiveness of solar energy. Did you know that once we have the solar panels installed, the sun's energy is free? Yes. It might be a bit expensive to set up solar panels initially, but in the long run, they can save a lot of money on electricity bills. Plus, as technology is being improved, solar panels they become more affordable for everyone. It's like investment in cleaner, cheaper future. So in this project, we are going to develop an efficient system that will accurately predict the solar energy by using machine learning and deep learning. Moving on, we did a comparative study in this project by building various machine learning algorithms as well as deep learning algorithms. In machine learning, we have built decision trees, random forest, voting regression. Coming to deep learning, we built deep neural network as well as convolutional neural network. From all these algorithms, which performs well will be used for finally predicting the solar energy in the front end. Moving on, we have used R squared metric, mean squared error, root mean squared error, and mean absolute error to evaluate all the models built in the project. After evaluating, we found that voting regression is performing well, so we have used it for deploying it in the front end for predicting the solar energy. So, how will this project benefit the society? Predicting solar energy helps energy companies know how much electricity they can expect from the sun. This helps them to plan better, like deciding when to use other energy sources or when to store extra energy for later. For companies building things like solar panels or wind farms, accurate predictions help them decide where to put their projects and how to make them work best with the existing energy system. It's like choosing the best spot for a garden to grow the most plants. Furthermore, to implement this project, we need software and hardware requirements. So the software requirements which are needed are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Moving on to the hardware requirements, we need Windows operating system, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. I have already told you that we built all these five algorithms. The first three are from machine learning and the last two are from deep learning. From all these five algorithms, voting regression performed well, so we have deployed it in the front end. So let us understand what is this voting regressor. The voting regressor, it is a ensemble technique that combines the predictions of two different base models that are decision tree and random forest in this project. These models are trained separately on the same dataset, but they capture different patterns due to their distinct nature. Each base model, that is decision tree and random forest, they individually generate their predictions for solar energy generation. The voting regressor then combines these predictions using a predefined voting strategy, that is averaging the predictions or taking the majority vote. Decision trees and random forests are both tree-based models, but they have different characteristics. Decision trees are simpler and prone to overfitting, while random forests they mitigate this by using multiple decision trees and aggregating their results. By combining these two models, the voting regressor benefits from their diversity and learns to generalize better. After combining the predictions from decision trees and random forests, the voting regressor produces a final prediction for solar energy generation. This prediction is often more accurate and robust than predictions from individual models alone, as it leverages the strength of both base models. So now we will execute the project. To execute it, first we have to open the code folder, which contains source code files. So here are the source code files of the project. Let us understand them. How will they be used in the project? So coming to the first folder, which is static, this folder contains files related to CSS, JavaScript, and Bootstrap files. These files are important for project styling and interactivity. The next one is templates. Here lies all the HTML pages used in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides the structure and layout for displaying content to the users. Moving on to the next file, which is app.py. This Python file, it encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content that to be represented in HTML templates. This is the model file, which contain the algorithm information, and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells and making it a popular choice for the data science. This is the signup.db file. This file is a database file which is used to store the user information. Moving to the next file, which is SPG. In this, we have data set that is used in the project. So we train all the algorithms using this data set. And here are the parameters which influence the solar power generated in power kilowatts. So the last column is the target column, that is nothing but generated power kilowatts, that is solar energy generated in kilowatts. So all these parameters influence the energy generated. Now close this. In this file, we have the test cases which will be used for deploying the front end. So these are the test cases to test the solar energy prediction. So we use all of these test cases in the project. So close this. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and click on enter. This will change current directory to the code folder's path. Here we can observe current directory is changed to the code folder's path. Now we need to compile app.py file. For that, we need to give the command called python space app.py and now click on enter. This will change. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying this link. I prefer Google Chrome, so I'll paste it in that. I'm pasting the link. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed by using Flask framework. So to execute, we need to sign up. Click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in. And here we need to provide our credentials, which are the username and the password to log in. So I've given my username and the password. Now click on sign in. We have logged in successfully and we are redirected to prediction page. So these are the parameters, which are the weather conditions, which are need to be entered based on the provided parameters. We will get the solar energy prediction. So coming to the first parameter, which is temperature at 2 meters above the ground. This refers to the air temperature measured 2 meters above the ground level. It indicates how hot or cold the air is at specific location. Moving on to the next parameter, which is weather condition. It is relative humidity at 2 meters above the ground. It is relative humidity measures the amount of moisture present in the air relative to the maximum amount it can hold at given temperature. It indicates how humid or damp the air is. The next one is mean sea level pressure. This is the average atmospheric pressure at sea level, and it represents the weight of the air above a specific location, and it is crucial factor in weather forecasting. The next one is total precipitation at surface level. This parameter measures the total amount of precipitation, that is rain, snow, sleet, etc., that falls at the Earth's surface over a specific period, typically in millimeters or inches. The next one is snowfall amount at the surface level. This indicates the total amount of snowfall that occurs at the Earth's surface over a given period, usually measured in millimeters or inches. The next one is total cloud cover at surface level. This represents the fraction of the sky covered by the clouds at the Earth's surface. It indicates how much of the sky is obscured by clouds, and it can affect solar energy generation by reducing the amount of sunlight reaching the solar panels. The next one is wind speed at 900 millibars. This is the speed of the wind measured at pressure level of 900 millibars. It indicates how fast the air is moving horizontally at that altitude. The next one is wind direction at 900 millibars. This parameter indicates the direction from which the wind is blowing at pressure level of 900 millibars. It is typically expressed in compass degrees. The next one is wind just at 10 meters above the ground. It is wind gusts are sudden increases in wind speed that occur over short periods. This parameter measures the maximum wind speed observed at the height of 10 meters above the ground during a gust. Angle of incidence. This is the angle at which sunlight strikes a surface, such as solar panel. It affects the amount of solar energy captured by the surface, with optimal angles maximizing energy generation. Coming to zenith, the zenith angle is the angle between vertical line that is directly overhead and the line connecting the observer to the sun. It represents the sun's position in the sky relative to the observer's location and affects the intensity of solar radiation received. The last one is azimuth. It is the compass direction from which sunlight is coming, measured in degree clockwise from the true north. It indicates the sun's horizontal position relative to the observer's location and influences the distribution of sunlight throughout the day. As we have understood all the parameters, let us enter them. So the temperature is 18.21, relative humidity is 19, mean sea level is 1023.4, total precipitation is 0, snowfall is 0, total cloud cover is 0, wind speed is 11.17, wind direction is 358.15, wind gust is 10.08, angle of incidence is 30.204805, zenith value is 53.0726, azimuth value is 218.91. We have entered all the parameters. Now click on predict. Here we got the prediction that the generated solar power is 2317.99 kilowatt based on the given weather conditions. It is the expected amount of solar energy generated at that given moment. So now we will enter other set of parameters. Click on prediction. Temperature is minus 1.95. Relative humidity is 91. Mean sea level is 1013.5. Total precipitation is 0. Snowfall is 0. Cloud cover is 100. Wind speed is 8.67. Wind direction is 228.37. Wind gust is 12.96. Angle of incidence is 60.2135. Zenith value is 82.3129. Azimuth value is 125.03395. We have entered all the parameters. Now click on predict. Here we got the prediction that 381.824 kilowatt is the generated solar energy at that particular given moment based on the weather conditions, which is very low. And now we will enter other set of parameters. Click on prediction. Temperature is 27.6. Relative humidity is 28. Mean sea level is 1019. Total precipitation is 0. Total snowfall amount is 0. Cloud cover is 11. Wind speed is 9.18. Wind direction is 295.56. Wind gust is 53.8179. Angle of incidence is 43.044113. Zenith value is 53.79. Azimuth value is 261.0395. Here we have entered all the parameters. Now click on predict. Based on the provided features, we got the prediction that 881.497 kilowatt of solar energy will be generated at that particular moment. So now we will enter other set of parameters and see how much amount of the solar energy will be predicted. So click on prediction. Temperature is 9.59. Relative humidity is 79. Mean sea level is 1010.5. Total precipitation is 0. Snowfall is also 0. Cloud cover is 100. Wind speed is 5.41. Wind direction is 86.19. Wind gust is 7.56. Angle of incidence is 88.9574. Zenith value is 72.91027. And the last azimuth value is 73.7336. Now click on predict. Here we got the prediction that the generated solar power is 399.05 kilowatt. It is the expected amount of solar energy generated at the given time. Now we will see the comparison graphs of the project. So click on graph. This is the correlation matrix, which represents the correlation between variables. Moving on, this is the R2 score comparison graph, where on x-axis we have algorithm names and on y-axis we have R2 score. From all the algorithms, we can observe that voting regressor achieved highest R2 score, so we can understand that it is performing well. Moving on, this is R2 score showing the comparison between DNN versus decision tree. Here on x-axis we have both of the algorithm names, and on y-axis we have R2 score for both the models. And this is for DNN versus random forest, and this is for DNN versus voting, that is voting regressor, and this is for DNN versus CNN. And here we have mean squared error comparison graph, where on x-axis we have algorithm names and on y-axis we have mean squared error. This is RMSE, which is root mean squared error, and this is the comparison graph of mean absolute error. Now click on sign out. In this way, just by giving the parameters that are weather conditions to the system, it will detect the solar energy.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.